All right, ready to predict some values? Here we go. There's a stats model method, which takes a data frame organized in a similar way to the one we use to fit the model and then makes predictions. We worked with the variable x for that regression. Let's check it out. X is a data frame with 3 columns, a constant, SAT, and attendance. This constant was actually added with the add constant method we used prior to fitting the model. As I told you before, it is a simulation of x0 and contains only ones. All right, let's create a data frame which we will use for predictions. We will organize it in the same way. It will have 3 columns, constant, SAT, and attendance. We will check 2 students, Bob, who got 1700 on the SAT and did not attend 75% of the lessons, and Alice, who got 1670 on the SAT and attended more than 75% of the lectures. In terms of coding, that would look like this. The new variable will be called new data. We want it to be a pandas data frame. The first column is called const and is always 1. The second column is SAT and has 2 entries, 1700 and 1670. The third column is called attendance and has 2 entries, 0 and 1. Since data frames usually arrange columns in alphabetical order, I'll overwrite new data with new data, but the columns will be in the order specified by me. Cool! As you can see, it looks identical to the data we fed to the model when we created the regression. I'll further change the indices for this example, but that's definitely not something you will ever need to do. The appropriate method that allows us to predict the values is the fitted regression dot predict. The fitted regression for us is in the variable results. This method has a single argument, the new data. Therefore, I'll create a variable called predictions, which will contain our predicted values. As you can see, the result contains the 2 predictions. I'll transform it into a data frame and join it with the first one. Please note that there are dozens of ways to do that. The predicted GPA at graduation for Bob is 3.02, while for Alice, 3.20. Alice scored lower on her SAT, but she attended more than 75% of her lectures, and she is predicted to graduate with a significantly higher GPA than Bob. That makes sense, but let's see why we actually needed the dummies. Had we used our previous model without the dummy variable, we would have predicted that Bob would graduate with 3.17 and Alice with 3.12. We can easily see the difference and why exactly we needed the dummy variable. Okay, this will do for now. In our next lesson, we will solve a real-life case. We will even use several dummy variables, which will ensure you will reinforce what you've learned here. See you next time, and thanks for watching.